Electric circuit. The bulb glows only when there is flow of electricity. The flow of electricity is known as electric current. When we connect one terminal of the cell to another terminal of the cell through a bulb, we create a closed path and the bulb glows. The path along which an electric current can flow is called an electric circuit or simply circuit. If the circuit, as shown in figure, gets complete, electric current flows through the circuit. This circuit is called a closed circuit. If the circuit as shown in arrangement B, C, E and F is incomplete, electric current does not flow through the circuit and as a result, the bulb does not glow. Such a circuit is called an open circuit. Electric current flows in a particular direction. In an electric current, the electric current of the electric cell is shown in figure by arrows. The cell, the bulb and the connecting wires are all parts of the electric circuit. Sometimes an electric bulb does not glow even if it is connected to the cell. This may happen if the bulb is fused. An electric bulb may fuse due to many reasons. One reason for a bulb to fuse is a break in its filament. A break in the filament means a break in the path of the electric current between the terminals of the electric cell. Therefore, a fused bulb does not light up as no current passes through its filament. Electric switch. An electric switch is a simple device that is used to open or close an electric circuit. When the switch is in the on position, the electric circuit is complete and the current is allowed to flow through the circuit. Activity 4. To connect an electrical bulb with an electric cell in different ways and see in which case the bulb glows. Things needed: an electric bulb, an electric cell, plastic-coated copper wires. The plastic coating at the ends are removed so as to expose the bare copper wires. Insulating plastic tape, a pencil. Method: connect an electric bulb with an electric cell using copper wires in 6 different ways and observe in each case whether the bulb glows or not. Arrangement A. One end of the wire is connected to the positive terminal metal cap of the cell and the other end of this wire is connected to the negative terminal base of the cell. If both the wires are intact, we observe that the bulb lights up as shown in the figure. Arrangement B. Using the same procedure as discussed above, we find that wire 1 is broken. The bulb does not light up in this situation, also as shown in the figure. Arrangement C. In this case, wire 2 is broken, so the bulb does not light up as shown in the figure. Arrangement D. Reverse the connection as mentioned in arrangement A. Connect the positive terminal of the electric cell with the D terminal of the electric bulb and the negative terminal of the electric cell with the C terminal of the electric bulb. You will see that the bulb lights up as shown in the figure. Arrangement E. Connect both the terminals of the electric bulb only to the negative terminal of the cell. The bulb will not light up as shown in the figure. Arrangement F. Connect both the terminals of the electric bulb only to the positive terminal of the cell. The bulb does not light up as shown in figure. Conclusion: when there is a complete path from one terminal of the cell to another terminal of the cell through the bulb, then only the bulb glows up. Arrangement A and D. The bulb will not glow if a wire is broken. Arrangements B and C. The bulb also does not glow if both the wires are connected to the one terminal of the cell. Arrangements E and F. How an electric torch works. Examine the inside of a torch. It has 2 or 3 cells placed in such a way that the positive end of one touches the negative end of the other cell. The cells are in series. These cells are the source of electric current. They are connected through a switch to a small bulb. The negative terminal of the cell presses against the spring at the base of the torch. The positive terminal of the cell presses against the metal tip at the base of the bulb. There are 3 metal strips. Metal strip A is a part of the switch. Metal strip B connected with the metal case of the bulb. Metal strip C connected with the spring. See the figure. While metal strip B and C are fixed, metal strip A can be pressed and made to slide. When the switch is pushed to the on position, the metal strip A is pushed forward so that it touches B and C, and the circuit is complete and the bulb glows. When the switch is pushed to the off position, the contact between metal strip A and B is broken and the circuit is incomplete. Now the current cannot flow through the circuit and the bulb does not glow. As a result, the light goes out. Electric conductors and insulators. Take an electric cell, a torch bulb fitted in a holder and some connecting wires, copper wires. Connect them as shown in the figure. A gap is left between the ends A and B of the connecting wires, so bulb does not light up in this case. Let us connect a paper clip made of sheet between the free ends A and B of the connecting wires as shown in the figure. We will see that the bulb lights up at once. This means that the paper clip of sheet allows the electric current to pass through it so that the current starts flowing in the circuit. We now connect a rubber eraser between the free ends A and B of the connecting wires as shown in the figure. We will see that the bulb does not light up at all. This means that the rubber eraser does not allow electric current to pass through it, so that no current flows in the circuit. Electrical safety. Replace the light bulb only when it is switched off and cool. Never touch electrical switches or gadgets when our body is wet. Don't try to repair or install electrical wiring or appliances. Do not touch electrical poles and transformers on the road. Do not touch a hanging wire on the road. Never fly kites near overhead power lines. Never join the electric wire with bare hands.